components mentioned in this diagram. Let me give you a quick heads up about these components. We are going to write multiple microservices during this entire session, and we will start with first component, and that is Spring Cloud Config Server. Spring Cloud Config provides server and client-side support for externalized configuration in a distributed system. With the config server, you have a central place to manage external properties for applications across all environments like development, QA, staging, production, etc. Second important component in Spring Cloud Framework is Eureka Discovery Server. Eureka Server holds the information about all client service applications. Every microservice will register into Eureka Server, and Eureka Server knows all the client applications running on each port and IP address. Next component is Ribbon Load Balancer. We will explore this component and understand how it can balance the load on the same microservices running on different ports. Later, I will show you how you can achieve the same through Eureka Server itself. Next is Zool API Gateway. Like any other API gateway, it handles all the requests and performs the dynamic routing and delegates the request to external microservices. It is also known as Edge Server. Next component is Spring Cloud Gateway. Spring Cloud Gateway is a non-blocking gateway. Means when using non-blocking API gateway, a thread is always available to process the incoming requests. These requests are then processed asynchronously in the background, and once completed, the response is returned. So no incoming request never gets blocked in case of non-blocking API gateway. The next component is Zipkin, which is used for distributed log tracing. As you all are aware, microservice architecture involves multiple services which interact with each other. So functionality may involve calling to multiple microservices. It uses Spring Cloud Sleuth to generate and attach the trace ID, span ID to the logs. This can be used by Zipkin and ELK for storage and analysis. Another related component is ActiveMQ. I will show you with real use case how you can configure ActiveMQ to get streams of logs from different microservices, and how Zipkin uses these logs for distributed tracing. I would also demonstrate to integrate a Spring Boot actuator in your microservices to monitor and manage application usages. We will use OpenFin for any API to API communication. I will cover error handling in microservices, and I personally believe it is really important part of entire microservices and Java ecosystem. We'll also quickly show you to configure Swagger for API documentation. I'm sure there would be a lot of takeaways for you after watching the entire session. As I have briefed you about all these components shown in the diagram, let's talk about the prerequisites and environment details. You need to have one Java standard editor like Eclipse or Spring Tool Source or any other Java supported IDE for writing and executing microservices. Regarding JDK, I'm gonna use OpenJDK 14 version. I'm gonna use Spring 2.3.4 release. You would also need Postman tool for executing APIs. Here is the port details used by our components. I'm going to use port 8888 for Spring Cloud Config Server. I'm going to use default port 8761 for Eureka Discovery Server. For Zool API Gateway Service, I'll use port 8762. Likewise, for Spring Cloud Gateway Server, I'll be using port 8763. For Zipkin, I'm going to use default port 9411. I'm going to create 3 microservices in this session. First one is Property File Access Service. This is going to use port 8100. Second service is Product Stock Service, which will use port 8200. Later, we would configure multiple instances of these microservices, which will use port 8101, 8102, and so on. Next is Product Inquiry Service. This service will use port 8300. Let's start with the first use case now, and this is to use a Spring Cloud Config Server configured with Git repository for accessing external property files. For this, I'm going to create one simple microservice named Property File Access Service, which will try to read the environment-wise property files stored in GitHub. But before we create service, let's create a Spring Cloud Config Server. Let's begin. Now, let's create our Spring Cloud Config Server. So I'm using IntelliJ IDEA as the editor. I can select the option called Spring Initializer. As you can see here, you can select multiple JDK versions. As I mentioned earlier, I'm going to use JDK 14. Just click on next. By the way, in Eclipse also you have similar feature called the Spring Initializer. In this screen, as you can see, there's a group, artifact, and this language selection, the package, Java versions and all. So I usually start by putting groups com.takeeffects.microservices. Since we are going to create a Spring Cloud config server, we can say takeeffects Spring Cloud config server. I'm going to use a type Maven project. Packaging is jar. Java version I'm going to use 14. I'm going to keep version as it is here. Click next. In this screen, as you can see, you can select your own Spring Boot. I'm going to use 2.3.4 because we are going to write a microservice for a Spring Cloud config server. We just need two components. One is the web component and other is Spring Cloud config server component. Just two components, that's it. Project name is going to be the same and say finish. Project is getting initialized. Takes a little time to set up the entire project structure, the framework. Now the editor has loaded the project, so you can go to src main. You will find one main class. The class name is takeeffects Spring Cloud config server application, which contains a main method. So this is going to be the default. You simply need to add one more annotation, and that is enable config server. That's it. You don't need to do anything else out here. Now go to resource. You will find application.property. You can use the same file name, but I always prefer to use YAML file, so I'm renaming it to YAML. Let's give the application name and set the Git repository detail as well as the server port information. Giving the Spring application name in YAML is going to be like this. So let me explain you what I have done over here. So I have given the Spring application name, which is exactly the same what you can see in this root folder name. The second thing what I have done is I have mentioned the Git URL, cloud config server Git, and this is the URI, and the last thing is server port. As I mentioned earlier, I'm going to use port 8888. So let me just give you the summary. I have created a Spring Cloud config server and annotated with enable config server. That's it. And this main class, Then I have renamed application.yaml file where I have inserted Spring application name and have also put the configuration for our Git URI. This Git URI where I have kept my property files. So this is hosted on GitHub with the TechFX environment variable repo, and if you go to clone, this is what that clone URI I have mentioned over there. As you can see, currently this repository contains 3 files which are nothing but a property file. One is a default property file, and this is what it is, and the name is TechFX property file access service dot property. It doesn't have any suffix later, so this we call it default property file. This file has got 2 key values. One is property file.name, and the value is something like GitHub new change one more time, some values, and second key is property file description, which also has some values. Likewise, we have 2 more property file specific to environment. So this property file, the suffix by -QA, and here is the names are same, but the values are different. So QA and QA environment property. Likewise, if you go back, there one more property file with the suffix of dev. So that specifies that this belongs to development properties, and here the key is going to be the same, but the value is changed. So now instead of QA, it is showing dev. So I'll exactly tell you how to access this property files while I will write microservice for accessing this file. For now, let's get back to IntelliJ. So this is what we have written. It's this very simple cloud config server. Now let's execute and see if it runs properly or not. As you can see, target folder is been created. If you look at pom.xml, you will see the version 2.3.4.release and the group ID and the name of this cloud config server. If you remember, we had selected 2 dependency. One was the web and second was Spring Cloud Config Server as a dependency. Other than that, the tests and the other dependent plugins are going to be the same. One very important plugin is Spring Boot Maven plugin. You would require this plugin if you want to run or execute your microservices out of that ID environment. For example, from the command prompt, if you want to run, you will need this Spring Boot Maven plugin. As we can see, the Spring Boot is initiated and now it's loaded. As you can see, the Tomcat server is up on the port 8888. So this was so easy to create a Spring Cloud config server. You must be wondering, I have not configured anywhere about the Tomcat, but it says starting service Tomcat. This is the beauty of Spring Boot, that it is integrated with Tomcat as an application server. So you don't need to configure, or you don't need to separately explicitly integrate that Tomcat. It comes as a bundle. Now let's create our first microservice, and that is property file access service. In our previous step, we had created a Spring Cloud config server and we had configured a Spring Cloud config server to run on port 8888. Let's create one new microservice which will communicate to a Spring Cloud config server to access property files kept on GitHub repository. Let's begin. For these microservices, we are going to have three dependencies. First one is Spring Boot DevTools. Second is Spring Web. And the last and most important is config client. Since this microservice is going to communicate with Spring Cloud Config Server to access property files, it is necessary to have config client dependency injected in our microservices. I'll show you in the POM. Okay, now project is initialized and loaded. As you can see, there are microservice empty project structures are created through Spring Initializer, and this is the default project file which has a main method gets created. Second important thing is the application property file, which is as of now is empty. So let me rename this to YAML. Now let's come to pom.xml. As you can see, this artifact ID, and this is the version 2.3.4 release. The name is going to be the TakeEffects property access service. It has got a first dependency called Spring Boot Starter Web. Second one is Spring Cloud Starter Config. This is what we had injected while we were creating a microservice. And the third dependency is Spring Boot DevTools. The other dependency will be the same. Another important plugin which I had mentioned during Spring Cloud Config Server as well. You need to have this plugin, Spring Boot Maven plugin, if you want to run this microservice from out of your ID environment. For example, it's like through command prompt with spring-run command. So you will need this. So now let's begin to create the microservices business logic. Since this microservice is going to communicate to Spring Cloud Config Server and then will access the property file, we would need to create three main Java classes. One is the controller. Through that controller you will create and access your endpoint. Second thing is a very plain Java beans, which you can call is value object. And third and most important is environment property component. So let's create one by one. As you can see in environment variable repo, there are going to be a multiple property file. Each property file has a name, suffix and prefix. So if you open one property file, the name is TakeEffects property access service dot property. It doesn't have any suffix, so you can call it as a default property file. I'll explain you the importance of this default file. Let me just quickly brief you about what this property file contains. So as you can see, this property file has got two keys values. One is the name and second description, followed by this prefix of property file. This prefix is very much important to you have to define this prefix in your configurator. So this name and description are the keys, and the values could be anything. Here I have just made some value like GitHub new changing one more time and all. You can have any kind of a string value. So we have name and description as our variable. So going back to IntelliJ, we'll create two variables. So now I have created two simple Java bean. One is a value object which have private string name and description, and I have created one constructor with the parameter of these two values along with the getter setter and the two string object I have created for this value object. Now I have created another bean with the same name and description with a getter setter. But if you see here, I have added couple of additional annotations. One is a component annotations, means this is a class as a component I have inserted here, and second is configuration properties. This configuration properties says that it's going to check all those keys which has prefix of property file, as you can see here. So all the keys which will have prefix with property file will be read. That's it. So now from the business side is done. Now since we had not provided any values to application YAML, so now let's provide the microservice name to the YAML. For that, string so we have defined application name in YAML and the port on which we are expecting this microservice to run. That's it. So now let's run this microservice and see. So now let's run this microservice and see what it does. So as you can see, Spring Boot got initiated and Tomcat is initialized on port 8100. Now it's saying starting, and then finally it says Tomcat is started on 8100. A couple of things, let me explain you like what happened. If you look at the line, first line, fetching config from server at 8888. This is what it was expecting to connect, but unfortunately it says connect time out exception on URL this. Because if you look at in our past step we had created, but that service is no longer running. That we are talking about Spring Cloud Config Server service. It's no longer running. So what we'll have to do, we'll have to open Spring Cloud Config Server. This we had created. Now let's run this server. So as you can see, no active profile set, but still Tomcat is sliced on port 8888 and now it's running. By exposing two endpoints, that's actuator. I'll talk to you about that later. Now let's focus on this. Tomcat is running on 8888, right? So if you go to your property service, you will have to just rerun this service and see what happens. Now if you look at the log file, it's again saying fetching config from server, and this time it says located environment takefx property access service with the profile default. I'll explain you the meaning of this. But for now, just check out the other things. So Tomcat is running on 8100. So now we are set, we are done. So now let's open Postman. So if you remember the URL, localhost 8100/access/ so just for cross check, so just open up your okay. Now let's create our controller. That's it. Now we have created two beans, simple Java beans, that's property access value, and second is property access beans, and now we have created property file access control. We have also created application YAML file which has Spring application name and the server port on which this microservice will run. Earlier we had tested this microservice by running on port 8100, which was successful. Now since we have added all those required classes, now let's restart the microservice. So as you can see here, is able to fetch the config server on localhost 8888 with the default environment profile, that's default. And so Tomcat is now running on 8100. Now let's go to Postman and say access property file, right? This is what actually we had created. So just to ensure, just copy and go to this and hit enter. Look what happens. As you can see, it is able to fetch property file and its key value. Its name is GitHub new changing, one more time it's changed, and the description is this. Now we are able to access property file. So in next step we will see how we can access this property file dynamically. So if runtime, if any property file changes, we are able to fetch that changed value. How? We'll look into our next step. Welcome back. In our previous step, we had created Spring Cloud config server, then we created a microservice which were communicating to Spring Cloud config server, and were able to fetch property files from GitHub to your Postman. As I had mentioned, there are 3 property files. How did this microservice determine that out of these 3 files, it has to access TakeEffects property access service.property. So if you look at, this is the property file it accessed. We had not mentioned this regarding this property file anywhere in our microservice, but still microservice was able to access this default access service.property. I'll tell you what happened inside. So if you go back to IntelliJ, if you go to application.yaml, I had not mentioned any default. So what this microservice says, that if you don't mention any profile, active profile, then it will take the default property file. Now this time, let's put that profile active detail here. What you have to do is, simply you have to say profiles and active. So dev. So remember, we had 3 types of profile. One was a default, second was dev, and third was QA. So I have just mentioned dev. So now this time, let's restart this microservice. If you look at, it's fetching config server on localhost 8088. It's locating the environment. But still, if you look at the profile, is default. However, we have mentioned profile active dev, but it's not taking. Let's find the reason why it is happening. Now the Tomcat is started on port 8100. So let's go to Postman and run this again. You will be surprised to see still it is fetching the default value. The reason is this microservice is not reflecting the profile environment. For that, what you have to do, you have to use actuator. That actuator will refresh the value. So if you look at our POM, we have not used actuator over here. Let's insert the actuator dependency. So what you have to do is just copy this and say Spring Boot starter and say actuator, and you have to save it. Now let's restart this service. What this actuator does, if you are aware, actuator can provide a lot of information about the microservices. For example, like a health information, the information about the endpoints, and many things and many more things. One more advantage of using actuator is that I can show you how you can utilize this actuator to refresh the endpoint. So let's see. So we have restarted our service, but still if you look at profile is default. So now I'll show you how you can use actuator to activate your profile, which you have mentioned in your application YAML file, profile active dev. So if you go to this thing and say send again, you'll find the same value. If you want to refresh, if you want to get updated value, you will have to use HTTP. It's running on localhost /8.100/actuator/refresh, right? And you have to use the post. Oops, you will have to add, we missed to add management endpoints. Include and say refresh. We'll talk about more values like refresh, health, info and all little later. For now, just focus on this, that include is equal to refresh. Now restart this service. So service is started. I'm going back. I'm accessing this again. Still has not reflected with the property file. So going to post HTTP localhost 8100 actuator/refresh and say send. Says property file dot name and property file dot description. And if you go to log file, now if you look at, it says DevTool property default active set string DevTool. Now fetching, and now if you look at profile equal to dev, located environment name takefx property access service profile equal to dev. This is what actuator has done. So now since the following profile are active, dev profile are active, if you go to your get endpoint, get method and say send, now look at the name equal to dev and description is a dev environment property. So now we have seen that now we are changing our environment variable as per the profile what we have set, active profile what we have set in application.yaml file. Now let's quickly check one more thing. Now I'm going to that dev profile and I'm editing this value, say like dev new, and I'm saying expecting changes and I'm saving it. Now if you go back to endpoint and say send, you still get old value. The new values are not getting reflected. If you want a new values, what you have to do is you have to go back to post, refresh and send. It means whenever you want to get new values, you will have to use actuator refresh. But in real life scenario, this is not possible every time, right? So I can tell you there are many approaches by which you can get dynamic values. One of the very rude way of getting dynamic value, every time whenever you are accessing, your property file by using a refresh command in your business logic itself. So let me show you how we can do that. For that, you have to go to controller and let's write one refresh actuator method. So public void let me brief you what I have done in this refresh actuator method. So I have used REST template object and I have put a base URL. This base URL value I'm going to give exactly what I had used here. Next, I have created HTTP header object. In that header, I have set content type application JSON. Next, I have created HTTP entity object where I have inserted header's value to this entity. And finally, I had created a response entity with a string type where I had set REST template dot post for entity base URL comma entity comma string dot class. The reason is this is string dot class because here we are expecting the string. That's it. So now you can use this to your call. Refresh actuator. Now let's restart the service. Now, once service is started, you can go to Postman. You don't need to run now this explicitly. Whenever you will try to hit the endpoint for accessing property file, what it will do? It will send request to actuator for refreshing the service, and every time you will get a refresh value. So now let's try out. So this time I'm saying editing new again and 1. I'm saving it. Now if I'll access this method, you will see now it's checking updated value. I've shown you how you can create a microservice which can communicate to a Spring Cloud config server to access the multiple property files based on your environment setting in your application.yaml file. If next time if you're changing to QA, or if you're not putting any values like this, then it will access a default, else whatever profile you will active here, so that based on this profile your environment property will be read. That's it for the session. In this section I am going to demonstrate you how one microservice can talk to other microservices and how Netflix Ribbon load balancer can be used to distribute the load between multiple instances of the same microservice running on different ports. Later in this section, we would also understand how we can configure Eureka naming and discovery service and how we can register all our services. I would also demonstrate how Eureka naming server can be acted like load balancer for multiple instances of the same service. To demonstrate, we are going to create two microservices. First is product stock service. This service will store product information, and the second service is product inquiry service, which will eventually be used for fetching product data from stock service. Now let me brief you about service structure. As I mentioned, product stock service will store product related data like product name, price, stock, availability, discount offer, if any available on this product. Since this service stores product data, we would certainly require some database, isn't it? I'm using H2 database for demo purpose. You can use any database like SQL or NoSQL. I'm using here Spring JPA repository for data persistence. Coming to product inquiry service, this service will primarily use to get the product information from stock microservice through API call. Since both the microservices will be used together, there are quite similarities in the field variables like product name, price, etc. However, there are a couple of additional fields are in inquiry microservices. like unit and total price for calculation purpose. As shown in the table, both the microservices will use some common libraries like DevTools, Web, Actuator, Eureka Client, etc., along with couple of additional libraries like H2 database and Ribbon Load Balancer. It is important to know that we are going to use FAN client instead of a REST template for API to API communication in inquiry microservices through proxy client interface. I would demonstrate you while we will program it. End of this section, I will demonstrate how we can load balance multiple service instances of stock service through Ribbon Load Balancer and Eureka naming service. I will also show you how we can use Zool API Gateway Proxy Server and Spring Cloud Gateway Server to route the API to API call. Let's get started. Now let's create product stock service. So here is the group I'm defining, com.takefx.microservices.product stock service. This is the way I define my package. You can define your own. Similar way, the artifact I'm defining takefx product stock service. This will become the name of that microservice, the description. And clicking next. Here you have to select Spring Boot version, and then I'm selecting the DevTools and Web. Since I'm using H2 database, I'm selecting Spring Data JP and H2 database. I'm going to use Eureka Discovery Client in future, so I'm just integrating that dependency. We'll have to wait for some time. Maven build is internally happening. Now if we'll go to main class, so you'll find one Spring Boot application. Let it be like that. Well, I typically prefer to use YAML, so I'm renaming it to application.yaml. You can keep as application.property as well. So here I'm going to define the application name, takefx product stock service, and the port I'm going to define now. As I mentioned earlier on that data sheet, I'm going to run on port 8800. Okay, so now let's first create bean package. As I mentioned earlier in microservices structure sheet, that I'm going to create product fields here, that like a product name, product price, product availability, product discount offer. To start with, this is ID. This is going to be a initial, that unique ID. So I'm keeping as long. You can keep as a string. It's up to you. Product price I'm keeping as a big decimal. Product availability as a string. I'm keeping discount offer as double, because in future there are possibilities like 20.5% or something in some decimal value. And I'm also defining port number, which I will take it later. As for now, just keep it as it is. Remember, we had mentioned that we are going to run stock services, the multiple copy of stock services. This is what that port, this will help us to identify what port that particular instances are running. So just for reference purpose, keep as it is. Now creating the constructor with entire fields, whatever we have defined there. Creating a getter setter as well. And finally, I'm just creating a toString, which is basically the overriding of the toString in case if we need to print that output. Now here I'm creating another package named entity. So whatever field we had created in product stock bin, we can copy the entire fields and we can replicate same here for the entity. Remember, I am not taking a port. I'm just taking any fields related to product, not related to any environmental variable. So to create entity class, you have to give the annotation as a string entity, and then we are going to define all those fields. So that ID will be represented as a persistent ID. So in Spring you can define annotation. Product name will be taken as a column in the product stock table, and here I'm trying to map the column name with my fields. This is going to be the table structure. So when we will write a SQL statement, we will ensure that the column what we are defining here should be same in that statement as well. So we are done now. We have defined, mapped. So we are done now. We have mapped all those fields with database column. Now we can create a getter setter for all those fields, entity fields, and then one more constructor that is going to be the empty constructor. We are done. So now let's create JPA repository file, which is going to be interface extending to JPA repository. This interface is going to extend JPA repository. I'm going to put two parameters here. One is the entity class name, which is product stock, and its primary key. If you remember, we have kept ID as a long. So this is what we need to put here. We need to define one more find by value, where I'm trying to little bit customize here, because I just want a product name and availability search. So rather than putting all those fields, I just need a composite kind of a field, like I'm going to search with product name and availability. So we have created this find by product name and product availability. Now I'm going to create a data SQL. As I told, we'll have to create a insert statement because we are using H2 database. So just for a demo purpose, what I'm doing when we are loading the when we are executing the microservice, at that time only we are creating in-memory database. So this is the table name product stock, and basically a SQL statement where we are saying, okay, map ID, product name, product price, product availability, and product discount offer. And just some sample values I'm going to put. So these sample values, what we are saying, okay, ID map to 1001, for product name as it is a string, map to say like bat, a cricket bat basically, and the cost is going to be the 5,000 rupees INR. So this is what actually a numeric value I have put. Again the availability yes or no. So this again is a string. And then finally the discount offer, which is double, so it's without the code. So let's create some 2-3 sample data. So when we will run this microservice, so this data will be loaded at that time. So I'm just trying to copy paste the same, and we'll change the ID values. So I'm just trying to copy paste the same value 2 to 3 times. I will change the ID values along with that product information as well. So first row was for bat, the price was 5,000. For ball, I'm just putting the price of 500 rupees. It's just an identical values. You can put anything in your data. The whole objective is to find when we will run this microservice, we should fetch this data when we apply through the postman. So I'll show you that thing. So I think we are almost done. Now the only thing is left is the controller. So let's create a controller package. So let's create a very simple single controller that get mapping method. Since it's our controller, we'll have to put REST controller annotation. Going to auto wire our product stock repository. If you remember, we had created. Later we will use this object for fetching the value from repository and pushing it to our entity. So I'm going to create one method. Return type is product stock bin. Say like that check product stock method, which will take two values. That's path parameter, the product name and product availability. So this we will be passing through our query string. So whoever API will be accessing product stock service will need to pass these two parameters, product name and product availability. For now, just complete this. We are just doing a request mapping. So get mapping. Here I'm doing check product stock, product name, then we'll be taking as a variable some sort of values, and the product availability, again that variable. So now let's create a entity class, entity object basically, and map this entity object with a repository. So I'm just passing product name and the product availability. So if this matches with our database, if this name and availability will be matched through the query, JPA query, that data will be fetched. Now, since this is entity bean, we'll have to map to normal Java bean, or you can say the value object. So this is what we are going to do, and so we will map entity bean to Java bean. So remember we had created a constructor with arguments. So this is what actually we are trying to map. Those we are taking product stock, get ID, product name, product availability. Next is going to be product discount offer. So get product availability, product discount offer, and finally let's put the port detail. So for putting a port detail, we'll have to auto wire the environment class. Through that environment class, we will use a property to access the port detail. So let's create an environment class object. So here environment dot get property. So here environment dot get property, and inside the property we'll have to put local dot server dot port. So this will give me the port information where this microservice is running. So we are done. So we have created bean, we have created entities, we have created repository, we have created the data, and we are loading this data when we are running this microservice. And now the time has come to run the microservice, and let's see how we are going to fetch the data. So one more thing, just we missed that. Basically here in the form, let's revise that. Okay, this JPA, then web. Since at this time we're not using Eureka client, so I have disabled it. Later we will enable this while we will configure it with Eureka naming and discovery service. So let's add one more plugin, that's Maven compiler plugin. Let's change the Java version to 14. Okay, cool. So we are all set. Now let's execute this microservice. This is the beauty of Spring, that Tomcat comes as an embedded tool. So you don't need to configure anything regarding Tomcat. And here you can see the Tomcat is now running on port 8800 without any problem. So now let's open Postman and run the API. So since we are using localhost 8800, it was lowercase, so I'm just changing to it. Let's quickly cross check about that. And let's quickly check about this path. Product name is going to be, if you remember, this product name is going to be BAT, and the availability, what we are checking is that it should be available, right? So now, okay, cool. So it is fetching the data. Now you can see when we search for BAT and the availability, yes, the data matched with database, and now it is showing this value. So we are able to see the ID, the name, the product price, availability, discount offer, and along with the port detail. So now we'll create another microservice named product inquiry service. This product inquiry service will be accessing product stock service for inquiring about the product. Now let's create product inquiry service. To start with, let's create a group first. This is the way I do create my group, com.takefx dot microservice dot my microservice name. So here in this case, it's a product inquiry service. The artifact, which is the name of the microservice, I'm going to create takefx hyphen product hyphen inquiry hyphen service. Packaging is going to be jar. Java version, I'm going to use 14, but since it's not there, I'm going to keep 11 itself. Later on we'll change. Description, product inquiry service, and then you can click next. Here, very first thing, I'm going to select the Spring Boot version, then dev tool, web. Since I'm not going to use any database for inquiry, I'm not going to select this. So, Eureka Discovery Client, just for dependency per se, just enable this. And now one more important thing is OpenFin. So we are going to use OpenFin client for API to API communication. As you can see, this is Spring Cloud routing. So product inquiry service will communicate to product stock service through OpenFin. And here we go. So click on finish. Will take a little while to bring that project up. So I think this is loaded. So now we can go to SRC main, my main class. As you can see, Spring Boot application. That's it. Let's not touch anything on this in this class. Now open application properties. I do prefer to rename this as a YAML file, but you can keep as it is. Now open the YAML file and try to put the microservice name over here. For that you can use spring.application.name. So here, if you remember, we had named this microservice to takefx product inquiry service. The same I'm copying here. Now let's assign the port. So if you remember, 8700 was the port we had specified in microservices sheet before the time we were talking about microservices structure. So that's it. Two things, Spring application name and the server port. It's enough. Now let's create bean package. In this package, we are going to create Java bean, a simple value object. We are going to create one simple Java bean class. Product inquiry bean. This bean will contain the field descriptions like the product name, the product price, its availability, discount offer. Very much similar what we had defined in product stock service class. product stock service microservice. So earlier in product stock microservice, we had defined, if you remember, ID, product name, product price, product availability, discount offer, since this microservice will access product stock service, a couple of more attributes we will need to define, like the unit, number of unit, means like a number of product, and its total cost. So this is what we have additionally defined here, along with the port specification. Now let's create getter setter for entire field objects and create a constructor as well. Argument constructor, and finally we'll create toString method as well. So we are done for Java bean definition. Since inquiry service will access stock service, we'll have to define proxy or the client interface. Through that, the fiend will communicate, right? So now let's create another package called client. You can also name as a proxy client or something. Let's create another package called client because inquiry service will communicate to product service through fiend client. So fiend needs a proxy or a client interface to be created where we will map the API call. So product stock client interface is created. This interface will have detail about product stock service API call, the endpoint of product stock service. So let's copy the endpoint from product stock service and paste over here. So let's copy this endpoint from product stock service and just paste as it is here. You can again copy the function, the method signature from product stock bean and copy it here. Only things you need to change is the return type. Because it's inquiry bean, you will have to change the return type to product inquiry bean. Since it's interface, you just need to create a signature out here. Let's now add fin client annotation to this interface class. So to enable fin client annotation, you can use fin clients. Give the name of this fin client. So to enable fin client, you will have to give the annotation to enable the fin client, add the fin clients and the name. So here, the name of your microservice. So it's a take effects product stock service. Remember, this is the name we have given for stock service. And one more entry you have to do is here, you have to enable the fin client here with the package name. The package name, it could be the entire, you can copy the entire package from this file and you can put it here. So you can copy the entire package and put it inside enable fin client as a string. So we are done here. So we have enabled the fin client by putting the annotation in our main class. Now let's go back to proxy client interface again and let's define the fin client. Let's put in the double quote and here we go. So we have set up the fin client proxy. What we are saying that we are enabling through this entire package and we have created client and that client is now communicating to product stock service. Now finally let's create a controller package. Since this is separate microservice, there should be an entry point. Because it's a controller class, we will have to give the annotation to REST controller. You will have to give annotation of REST controller. Then you will have to give the entry point mapping, and since this controller is going to access the fin client, you will have to auto wire by giving the reference product stock client. And now let's create a entry point for inquiry service. So user will be accessing entry point of inquiry service, and internally inquiry service will make a API call to stock service through fin client. Since it's inquiry service, there should return type should be inquiry main. And now let's put entry point mapping. Because it's an inquiry service, you can have a product hyphen inquiry, then the name says about the product name and the argument. Again, I am using the argument as a name, and then second argument is going to be the availability. This is again about the product availability. If you remember, in our product stock service also we were having two parameters, product name and availability. Since this inquiry service, we are going to have couple of additional fields like unit. The unit specifies the number of product you are looking for, the count you are looking for, and that's it. So name, availability and unit we are taking as a path variable. Both are as a string, but if you look at the unit, is going to be the integer path variable int unit. Now we have these three variables. Now let's pass this variable to fin client through client proxy. So for doing that, we'll have to create a proxy. For doing that, we'll have to create an object of product inquiry bin, and then we can call through client the check product stock. Remember, this is what we have created inside our client package. So this is what we are calling. This is what we had created, right? And basically this signature we had copied from stock microservice to inquiry microservice. So you just need to call a single line statement, and this is what the rest the fin client will do for you. So now product inquiry bean has the data about product stock service. So now let's map this value to the product inquiry bean constructor so that data gets mapped from stock service to value object. Because we are going to calculate the price based on the number of unit of the product, you will have to do you'll have to define couple of variables to get that unit multiplied by the product, the price. So for that, what I'm doing, I'm just creating a couple of variables, local variables like a double total price. The total price will be get total price multiplied by the number of unit. This is what actually we are trying to do. So extracting get total price from product inquiry bin and then multiplying by unit. The unit is the input passed by user. Similarly, for calculating the discounted price, you will have to extract first discount offer, and then you will have to create another variable where you will be manipulating it, that percentage amount to the price amount. So this is what the discounted price we are saying. Discounted price equal to so this is what we are now calculating about discounted price. The discounted price equal to total price minus total price multiplied by to get that percentage out from this. So now we have total price, now we have discounted price. Now let's set this entire value to our Java bean. So little tedious because we got so much values. Here is going to be the name. Name is nothing but a product name. And next is product price. Should be product price. Next is product price. It should be product price, not product total price. After name, it should be product price, not a total price. So now this is corrected one. This one comma is missing. So yeah, so comma is missing. Next will be the product availability, which were passed as a path variable. Next comes product discount offer. Then the unit, the number of unit. And then discounted price. So remember we had calculated this discounted price. And finally the port detail about where stock service is running. So now let's review the Maven POM. As you know that we had taken the dependency of web. Since we are not using Netflix Eureka client as of now, so let's disable that. The OpenFin we are going to use, this is Spring Cloud Starter OpenFin. And then let's put one more plugin of that compiler plugin. So this will enable you to compile and run anywhere. Not within the IDE environment. You can, once you add this Maven compiler plugin, you will be able to run this Spring Boot application as an application anywhere. So here, as I had mentioned you, that I'm going to use Java 14, but since that 14 version was not enabled while we were creating the project, so here we have to manually change. Now let's review all these classes and interfaces. So before we run product inquiry service, since inquiry service is going to communicate to product stock service, please let's ensure that stock service is running. So now we have run the stock service. Now let's go back to product inquiry service. So stock service is running now. Let's go back to inquiry service. Okay. So now, yes, we have done all the setup. Now let's run and see. Cool. This is the Fin client name, and this is what we had copied, the signature and the entry point from stock microservice. And this is what we have defined in the controller. So what we are saying that when the request comes to the controller through this mapping path, uh, this method is getting called. This method is anyway calling to client proxy, and it maps the product stock object to product inquiry object. Oops, something went wrong. So it looks like, okay, we had missed one thing. Yes, so we had missed one very important thing because we are not using any load balancer or not using any kind of naming registry service. So here you will have to specify where your product stock service is running. So along with the host name and the port, you have to define manually. We are done here. So now Tomcat is getting up and cool. So now it's running. Now let's check through Postman and see whether we are able to access the entry point of inquiry service and see if an inquiry service is able to access data from stock service. So as you know that inquiry service is running on port 8700. So this is the entry point. We need to specify the name of the product, the number of units, and availability. And here you go. So cool. We have got all the information. The ID is there, product name is there, product price is there, availability is there, discount is there, unit is there, but here you see the total price is 0. Must be something wrong, like in our calculation. Let's go back to inquiry service and let's see where we have done something wrong. So please now we can open the controller. Yes, this is here we had done wrong. So instead of get total price, we will have to call the getter of get product price. Get product price. And then convert into double and then multiply by unit. So I had wrongly given the getter name. So yes. Now let's rerun the inquiry microservice. Okay. Again, execute this URL. Okay, now here you see all the data are coming as per our expectation. Cool. So we are done. So far we have learned to create basic Spring Boot microservices and how through Fin client we can call other microservices entry point. For understanding this, we created two microservices. One is stock service and other is inquiry service, and we were able to make API call from inquiry service to stock service through Fin client. Now in this section we are going to learn how we can run multiple instances of stock service on different port and how we can enable Spring Cloud's ribbon load balancer in inquiry service to access multiple instances of stock service. For doing this, let's create another instance of a stock service. As you can see here, one instance of a stock service is already running on port 8800. For creating another instance, in IntelliJ, it is quite easy to run multiple instances. of the service with different port. For that, you have to go to edit configuration option here. There is one option called copy configuration. Once you copy configuration, you will find another instance in that list. So go and change it to 8801 or whatever name you want to give. Since I'm going to run another instance on 8801 port, I'm just specifying the name. And the next thing what you have to do is on VM option, you have to specify the port. So for specifying port, you have to do so through -d option, you can specify the server.port equal to 8801. Apply the change and OK. So now you will find two instances in the drop down. So select the second one. As you can see here, an option is enabled now for 8801. Just run it. Now you can see another Tomcat instance is up and running. And here you can see Tomcat started on port 8801. To ensure whether both the ports are working or not, you can go to Postman and check. So I'm here, Postman, as you can see, I'm just sending the data. So yes, I'm getting a response from port 8800, and this is what actually port equal to 8800 is specified here. Now, since we are running on another instance, let's change the port and hit. Now you can see the response has come from 8801 as well when we are changing the URL. So this ensures that both the ports are working. Now, next step is let's enable Spring Cloud Ribbon Load Balancer in Inquiry Service. And for doing that, go to Inquiry Service. As you can see here, earlier version through Fin client, we had specified the URL, hard-coded URL, because we had only one instances running. So now since we are going to enable Ribbon Load Balancer, we will modify this class as well. And so now step 1, go to pom.xml, and here specify the dependency for Ribbon Load Balancer. So this is the dependency. So this is the dependency I'm talking about. So the artifact ID, as you can see, Spring Cloud Starter Netflix Ribbon. So now as you can see, it's resolving the dependency. Yes, dependency got resolved, and now we are ready to execute through the ribbon. The second step what you have to do is you have to go to interface, the product stock client interface. As I had told you that earlier version we had to specify the hard-coded port over here. So now just copy this line and remove the URL from this line. So this much change you have to do in this interface. Now go to application YAML, and in application YAML you have to specify the ports. So for doing that, what you have to do is you have to take the name of the service, go to application YAML and annotate it. So what we are saying, this is what we are saying, take effects product stock service. This is the service name, and then we are saying ribbon, and then we are saying list of services. This is the syntax. So as you can see, this is a syntax. You have to put the ribbon and the list of servers equal to, these are the two instances you have to specify. One is 8800, another is 8801. And now let's see what are the changes we have done, then we will run this service. So first thing what we have done, we have added the dependency of ribbon here. Step number 2, we have made changes of inside the fin client annotation. We have removed the URL, and instead of putting the URL here, we are putting the URL in our application YAML, and this is the third change. And once this change is done, that's it. You have to restart your service. Now the service is getting restarted. Cool. So now you can see the Tomcat started on port 8700. Now let's go to Postman, and here let's try to run this option. So localhost 8700, the same URL earlier we used to hit. Now if you'll hit again, you will be able to see the result. So that result has come from port 8800. Next time when you are hitting this, or that couple of times, you will find this ribbon is balancing the load between two instances. Here you can see. Next time when we are hitting the same URL, the response is coming from 8801 port. So this way, so look, so every time when you are hitting the same URL in Postman, you are finding the responses are coming from both the instances one by one. So ribbon is working. This way you can run as many instances as you want. You simply need to put the entry inside the application YAML file, and ribbon will take care for the rest. But you must have observed that even this solution has got some limitation in terms of, as and when you will create, you will add or remove the instance, you will have to go to the microservice and make the changes, right? You definitely would not like to do in real-time environment, kind of a production environment, right? So how you can get rid of it? It's quite simple. You can do it through Eureka naming and registry server. How? I will demonstrate you in next section. I am going to demonstrate you how you can configure Eureka naming and registry server for our both the microservices. And I will also demonstrate you how Eureka naming server balances the load between multiple instances of stock service without enabling or configuring anything extra to the service. So let's get started. So you have to create Eureka server first. For doing that, in IntelliJ, you have to go File, New Project, and here you can select the Spring Initializer. Since I'm using Java 14, I'm just selecting this option. You have to specify the group. So So in group, I have specified com.takefx.microservices.takefx Eureka naming server. The artifact ID is going to be takefx Eureka naming server. I'm just going to keep this language and packaging as it is. Later section, I will update the Java version to 14. I'll show you how. And click next. So even though if you don't select all these things, it's fine. What you have to do is go to Spring Cloud Discovery and just select Eureka server. And yeah, specify the Spring Boot version, because I am creating all our microservices with Spring Boot version 2.3.6. I'm just picking that version. Project name is going to take effects Eureka naming server. Inside this location, I'm clicking finish. It will take a while to load because in background IntelliJ will resolve a lot of dependencies, will create the project structures and all. So yeah, it's almost done. So as you can see here, this is my main class. For enabling Eureka naming server, you simply have to go and annotate enable Eureka server. Let's go to POM and check the entire dependencies. And as I had mentioned you, I'm going to change this Java version to 14. Here you can see the dependency. And last but not least, because I always add this plugin to my microservice, this allows me to run microservice from anywhere, even out of the ID environment through command prompt. Through command prompt you can run. However, this is just an optional. If you don't want to specify, don't do that. It's not going to, there is no dependency of it. So second thing is go to application.property. I'm renaming it. Specify the application name. Specify the port. This is the default Eureka port 8761. I'm going to keep the same. Just save it. And we are done with Eureka naming server. So now let's run this service. Now open any browser. you can see when you type localhost colon 8761, you will find Eureka is up and running and is saying currently instance registered with Eureka. There is no instances available. There are some instances detail, IP address, and status is up. So now since Eureka server is up and running, we need to register our microservices to Eureka server. So let's start with stock service first, and then subsequently we'll go to enable inquiry service. So go to POM first, and here, if you remember, we had disabled the Eureka client dependency. So now time has come to enable it. So I'm just enabling it. In earlier version of Eureka, we had to specify the Eureka default URL. But now, since we are using the newer version, we don't need to specify all those. However, you can still specify, but those are optional now. So I'm not going to do any changes over here. In earlier version, we also had to specify discovery client annotation here, as I mentioned, because now it's no longer mandatory, it's all optional. So just there is some background noise, so So the earlier version, we had to specify the discovery client. There was a annotation. We also don't need to specify any annotation over here. So what we have done so far, we have just added the dependency of Eureka client, and I'm just stopping both the instances. So just add the dependency and you are good to go. So I'm starting my stock service one by one. So this is the first instance I'm restarting. And this is the second instance. So now, if you go to Eureka web interface, you can see there are some entry. The very first entry is Eureka naming server itself. It shows is up and running on 8761. The other entry, if you can see here, that available zones are 2 and up 2 instances. So the first instance is 8800. Let's add inquiry service also to Eureka. So to enable inquiry service to Eureka, you have to go to pom.xml, just enable this dependency, save it. As I had mentioned in earlier stock service, we don't need to put any entry, and we are good to go. Now if you rerun this, now I'm restarting the service. Once it started, we'll go and check an web interface of Eureka. As you can see here, see, discovery client, it's got discovered, right? And the services started. Now go to Eureka and refresh this. So now you are also finding the product inquiry service is registered. Now as a next step, because we have enabled Eureka naming service, earlier we were executing 2 instances of stock services and we had configured ribbon as a load balancer in inquiry service to fetch the data from both the services. Now we just need to remove all those ribbon setting. So very first thing what you have to go to service YAML and remove this entry. So here I am disabling it, I am commenting it out. I'm going to product stock client interface. Here you don't need to do anything, just keep as it is. This is absolutely right. So what we are saying, the fin client is going to talk to stock service and this is the name of the service, and from application YAML we have removed that and we are expecting Eureka to find the instances, whatever instances that stock services are running. So whatever instances stock service has, that Eureka naming server will understand that and it will serve data for you. So now we have restarted both the services. So time to check through the postman. You simply need to execute this and you can see here data is coming from port 8800. So next time when you are hitting, it is now coming from port 8801. So cool. So let me recap whatever we have covered in this section. The first thing, we have created Eureka naming server and specified the port to run on 8761, and we registered both our services to Eureka naming server, and we restarted the service, and when we restarted we are able to fetch the data from both the services. Let me show you another thing. Even if you create another instance of your stock service, say like, okay, I'm going to edit configuration and I'm adding one more instance of it, and this time I'm running on 8802. So here I'm specifying the port 8802 and I'm applying, I'm clicking OK, I'm running this. So now 3 instances of stock service is running. One is on 8800, another is on 8801, and now this is the fresh one which is running on 8802. Now if you go to postman, so sorry, first let's check in the Eureka web interface. So now you can see there are 3 instances of product stock service are running on different ports. So now if you go to postman, and now if you are trying to hit, so initially it takes some seconds, like 10 or 15 seconds. Once the server is completely stable, it will start. Yes. So now you can see 8801, 8802 and 8800. So now you can see all these 3 services are up. When we are hitting first time it's 8800, second time it's coming 8801, and this time 8802. So Whatever instance you create, that Eureka naming server takes care of that and balances the load between that. So that's it for this section. So in next section, I'm going to demonstrate you how to enable routing services through Zool API Gateway Server and Spring Cloud Gateway Server, which is called non-blocking API gateways. In this section, we are going to learn to configure Zool proxy server and Spring Cloud Gateway Server to enable routing service on inquiry service to access the inquiry services endpoint. To do so, let's first create Zool API Gateway Service. I've opened new project, selected Spring Initializer. Let's give the group ID. So what I have done, I have specified the group package com.techeffects.microservices.zool API gateway service, given the artifact ID name, which is going to be the microservices name as well. I've kept the language and packaging as it is, Java version 11. Later on I will change to 14 as I have done in my previous services as well. Description I have specified, and that's it. Here I have selected Spring Boot version again 2.3.6. Directly go to Spring Cloud Routing and select Zool. As you can see, Zool is now in maintenance mode, almost like deprecated. Spring Cloud is trying to recommend you to utilize. Spring Cloud is recommending you to use non-blocking API gateway, and that is the Spring Cloud API gateway, which anyway I'm going to touch base in next section. Just enable a couple of packages like DevTools and Wave as part of the practice. So here what we have enabled is Spring DevTool, Spring Web, and Zool API Gateway. Will take a little while to enable all those dependencies. So now it's ready. So if you go to pom.xml, here you can see, if you go to pom.xml, here you can see Netflix Zool dependency is enabled along with the DevTools and Web. As usual, let's add the compiler plugin. Now go to src main Java and open the main class. Here you have to enable Zool proxy. Once you enable this, go to application property. As I have mentioned you earlier, I always like to use YAML file. So I'm going to refactor this to the YAML. And one more thing, you can even change this application to Bootstrap. So as per the preference, Bootstrap property file or YAML file gets the first preference. So I'll show you how this works. So I'm changing this time bootstrap.yaml file refactor, which is same like application YAML file, just matter of setting preferences. So now give the application name, AKFX, Zool API gateway. So specify the port. You can specify any port, 8765, anything you like. Okay. And now you have to specify the routing detail. So before we specify the routing detail, let's first run the service and see whether it's up or not. So here I'm running the service. While it is running, you may also go back and specify the Netflix client, so you will be able to see whether Zool is registered or not. For doing that, you have to enable the dependency of Eureka client inside the form. So here I'm adding. Once you add the dependency, you got to restart the service. It takes a little while. Now the service is started. When you go to Eureka, refresh that. Now you can see take effect Zool API gateway server is added. So now Eureka knows that we have registered Zool API gateway server. So if Zool API gateway is going to access any services, naming server will know that and will help to serve the request. So now let's go to YAML file. Now let's go to YAML file, and as I had Now let's go to YAML file, and as I had mentioned you, let's define the routing. So for defining the routing, you have to apply this command. So we are done. So what we are trying to specify, that we are saying that this is routing ID, and we are specifying the inquiry service endpoint. That the whole, let me explain you the whole objective of enabling Zool proxy is, we are going to run inquiry service not directly with 8700 port as we have done so far, right? So now going forward, we will be accessing inquiry service through Zool proxy, say like through 8765 port number. So to enable that, we need to specify the routing. So for product in, so here I'm specifying the name, the route name, and says anything which starts from product inquiry. If we are specifying anything, let's redirect to localhost 8700. So this is what the instruction I've given. So now let's save it and restart it. So now you can see service is up and running. So go to Postman, open the Postman, and as we were accessing the URL of product inquiry through the 8700, this will still run without any problem, and it will be able to access the data. Now let's copy this entire thing and paste it here. Select a new thing. So here what we are changing, the port number, we are going to use the port number of our Zool gateway proxy. So for using this we have to specify the, for doing this you have to, for accessing this we have to additionally specify the, for doing this, for using 8765 you have to again repeat, for accessing inquiry service through 8765 you have to additionally specify the service name. So in this case we are saying take EFX product stock product inquiry service, enter. So look, now we are able to access the, now look, we are able to access the inquiry service endpoint through Zool proxy. So as you keep on hitting, you're seeing that it's now redirected to different distances. So now 8802 is responding. Next time when you again hit, it's 8801 and so on. So this is what actually we have done so far, that we have created a Zool API gateway server. Inside that Zool API gateway server we have specified the proxy. We have to, inside the Zool API gateway server we have specified Zool routing, and since we have single endpoint for product inquiry, this is what we are specifying. This is what we are specifying here. In case if you got multiple, you may provide the multiple routing name and URL. So that's it here, and we also have enabled Eureka client with Zool API proxy, and that is the reason it is now registered here. We can see Zool API gateway server is registered to Eureka, and then we were able to access the inquiry service endpoint through 8765, which is Zool API proxy port. Okay, that's it for now. I just want to highlight one thing, that this is just an introductory session for Zool API Gateway. There are really a lot many things which can be performed through any API gateway, and this is really a very vast topic. As I'm going to cover almost all the Spring Cloud components in a single session, it is very difficult to deep dive into each component, right? What I will do, I will create component-wise separate session where I will give much more insights about all those components and upload it to my channel. Okay, now let's come to the topic and create Spring Cloud API Gateway service, which is also called non-blocking API Gateway. And for doing that, let's create a service. Now to configure Spring Cloud API Gateway, you have to create a new project. Specify the group. Specify the artifact ID. So the same artifact ID is going to be the service name as well. Specify the Spring Boot version. Select the default dev tool. Now go to Spring Cloud Routing and select this gateway. So we got only two dependency. One is Spring Boot dev tools and other is the Spring Cloud API Gateway. Next, and what you're saying is finish. So our Spring Cloud API Gateway service project is created. Now I'm going to src main Java, open the main class, and okay, everything is fine. Let's go to application.property. Let's rename this application.property to YAML file. Let's open it. Provide the Spring application name. Specify the port. Now let's run and check. Let's specify the Netflix Eureka client dependency. We missed to add that. So let's see, Spring Cloud Starter Gateway is added. starter Netflix Eureka client dependencies added, DevTools dependencies added. One more plugin let's add here regarding the compiler plugin. So all these dependencies are added. Now let's restart the service. So we have restarted the service. Okay, it's getting up. The couple of things, let me highlight you. As you must have seen, the other services were using Tomcat to start the service, but here you can see Spring Cloud API Gateway uses Netty to start the service. So this is the difference I wanted to highlight you. So next step is go to application YAML and add the routing. So to add the routing, what you have to do is Spring Cloud, you can select Spring Cloud Gateway Routes. So this got added on top, Gateway Routes, and then specify the ID. It could be anything here. Since I'm going to access stock inquiry service, so here I'm saying stock inquiry, and now let's specify the URI. Remember, we are running stock inquiry on port number 8700. This is what we have specified. Now let's specify the predicates. Specify the predicates path. Defined. So since we have single entry point for stock inquiry service, and so this is what actually we are defining. We are saying that for this route, this is the ID and this is the URI. So if anything comes from this path product-inquiry, then please redirect to localhost 8700 with this predicates. That's it. So you can now rerun this service. Once the service is up, we can go to Postman and try to execute the URI through 8900. Yes, okay, the service is up now here. So what is saying? Updated port to 8900 on the Netty port. And one more thing, let's go, because we have added the dependency of Eureka client. So let's go to Eureka and see whether this dependency is added or not. So as you can see here, take effects, Spring Cloud API Gateway is up with port 8900. Now go to Postman. So here let's copy the entire URL here. Let's go to new and paste it here. Instead of 8700, just write 8900 and hit the service. Now you can see that we are able to access product inquiry endpoint through 8900 API gateways routing. If you keep on hitting this 2-3 times, all these instances values will be fetched. So this time the response is coming from 8801. Again executing. Now response is coming from 8800, and when I click again and again, now it is coming to 8802. The reason, because we have run 3 instances of stock service. So the API gateway is working with routing enablement. I just want to add one more thing. So far we have seen how we have enabled the Spring Cloud routing for inquiry service, and we were able to access the inquiry service endpoint through Spring Cloud API gateway, right? So as you can see, this Postman, we executed this Postman endpoint by using API gateway URL, and we are able to get the data from all those instances of stock service. For doing this, we configured the routing service in application.yaml file. Additionally, I will show you how we can enable routing through other way around, like by using configuration file. Both are the same, and it's just a matter of choosing the option. Now, let me demonstrate you how we can do it through config file. For that, let's create a new package, call it config. So right click to that main package, and now I'm creating a child package inside. So now let's create a new class. You can name anything. So for like I'm naming it like cloud routing config. Since this is a configuration file, just annotate it with the configuration, and primarily this file will have one method, and this method real time will be a route locator. So we will be writing one method with a return type of route locator and the parameter of route locator builder. So I'll show you how we can do this. So I have used route locator as a return type and given the parameter of route locator builder. Through this builder, inside this route, use a predicate. Use the path. So remember, we had used the path exactly as an application YAML. So the same path we can use. So I'm copying this path from here and pasting it in a path. And now let's go to application YAML. Copy the URI. Just put it inside the URI. Give the ID. You can again copy this ID from here, stock inquiry. And finally, build this. So that's it. This is the way you can build the route. If you don't want to use through YAML file, so you will need to create a class. This class will have one method, return type of route locator, with the argument route locator builder. Through this builder, you need to create a predicates exactly same what we are defined in application YAML. This predicate will have path, the URI, and the ID. That's it. So now for executing this, you will have to disable, you will have to comment out. Just save this, restart the service. Okay, service is started. Go to Postman and execute the same. Oops, there is one mistake. So you have to define the bin here. We missed to define the bin, so restart it. So now service is up. Go back to Postman and hit the same URL. You are getting the data, right? So this is the data we were expecting. So from all these three instances. So now let me recap. So we discussed about how we can configure routing. First way is to do it through application.yaml, and second way is to write a config file with the help of route locator. Welcome back. In this section, I'm going to demonstrate you how we can integrate Zipkin as a distributed tracing in our microservices architecture that helps collecting timing data needed to troubleshoot latency problems in service architectures. We are going to configure Zipkin distributed tracing server with the help of Sleuth and RabbitMQ components. Sleuth is a tool from Spring Cloud family. It is used to generate the trace ID, and RabbitMQ will be used as a data collector in this case. There are a couple of prerequisites for configuring Zipkin. First one is RabbitMQ server itself, and I assume you already have downloaded it from rabbitmq.com website and have configured in your environment. Likewise, you can download latest zipkin.jar executable file from zipkin.io website. Since I am using macOS and I have installed RabbitMQ through homebrew command at user local admin location, now let's follow steps to enable distributed tracing. So the very first thing what you have to do is you have to open a terminal and run the RabbitMQ through this command. So user local admin RabbitMQ server. This will start RabbitMQ server in your machine. Now it shows okay, starting broker. So RabbitMQ server is up and running. Next step is you need to execute zipkin.jar file. So for that, open new terminal. Since I have downloaded my zipkin.jar in my Eclipse workspace, we have to apply this command. So you have to provide the RabbitMQ URI. Since I am running RabbitMQ in my localhost, so the URL would be like amqp colon localhost. If you are running on some remote host, you need to provide the IP address for the same. The next section of command is java-jar. This you require to execute any jar file, right? So here I am applying java-jar zipkin server, and this is my zipkin version 2.23.0 executable.jar. So now it shows that zipkin is running, and this is the URL. So we are almost done. Let's enable the zipkin in our microservices, and for that open the microservices pom.xml and add these 3 dependencies. So I'm going to add these 3 dependencies to my first microservice, which is product stock service. So here I have opened pom.xml file. So down here you can integrate. So I have added these 3 dependencies. So first one is Spring Cloud Starter Sleuth. Second one is Spring Cloud Sleuth Zipkin. And the third one is Spring Cloud Starter Bus MQP. You need to add these 3 dependencies and you are done. Once you have added these dependencies, you don't need to do anything. We have added these 3 dependencies and we are done for this service. Now let's start this service. So I have got 3 instances of this service. First instance, which is running on port number 8800, as you can see. Second instance, I am running on port number 8801, and third one is I am running on port number 8802. So I will restart the service one by one. So I am now starting 8801 service. I'm going to 8802 and starting the service as well. When this service is getting started, we can go to now product inquiry service and make the changes. So this is the product inquiry service. Here also we will have to add the dependency for Zipkin and Sleuth. So I have added these 3 dependencies again, and now let me refresh this dependency. Now start the service as well. So now I am starting it. I am going to add dependencies to our third microservice, which is Spring Cloud API Gateway service. So this is my Spring Cloud API Gateway service. I'm going to add these 3 dependencies over here as well. So other than adding dependencies, I have not done anything. I have just added the dependencies and I'm restarting the service. Now let's go to our browser and see whether the service are up or not. So we can see here Eureka naming server is up and running on 8761. Likewise, the product inquiry service, which is now up on port number 8700, and there are 3 instances of product stock service which are running on port number 8800, 8801 and 8802. So now let's go to Zipkin and run the query. So still there's nothing because we have not done any kind of activity or we have not accessed any endpoint. So now let's go to Postman and let's start executing the service endpoint one by one. So in first place, I'm directly executing the product stock service with this 8800 port. So now I have executed this and now I can see that data is fetched, that we got response. So if I go to Zipkin and I run the refresh, as you can see here, this one entry. We will see those entry details later. Now let me execute the services one by one. Now second, we are going to execute the service through our inquiry service, so which is running on port 8700. So we are executing endpoint of inquiry service, and internally inquiry service executes the endpoint of stock service through FAN client. So now I'm executing this as well. So as you can see, 2 times I have executed, and there are that got response from 2 different instances, 8801 and 8802. And now again, if you run it, you will get the response from other instance, which is 8800. Now I will go and execute this through our API gateway. So here my API gateway is running on port number 8900. Now let's execute it. Okay, now let's go back to Zipkin dashboard and run the query. Look at, you will be able to see there are multiple entries now. So let's check one by one. So at first place, we had directly executed our microservice on port 8800. So this is this. So if I click on this show, it says that we had executed a get method, and this was the URL, check product stock product name. So this is the URL, and if you look at the overall, the response time got executed on 0 ms, and the entire that from request to response it took 613 ms. So if you click on this, you will be able to see what exactly happened, what time it got that request started, and that response was serviced. So go to show all, and here you can see relative time, which is 0 ms, and the server finish time is 613. And at both the place you can see the take EFX product stock service was the server initiator, and the server response he was able to give you the response within 613 milliseconds. So likewise, if you go back, and now let's check inquiry service. Remember, we had executed twice or thrice, I guess, right? Yeah, thrice. So this is the first one entry, the second entry is this, and third entry is this. So just open any one entry. So I'm just trying to open the top one, and now in this situation you can see there are 2 entries. So product inquiry got initiated at 0 ms, and the entire response was served in 1.844 second, as you can see here. So executed, initiated at 0 ms and served at 1.88 ms. Second line, as you can see, that red one, it shows that got initiated over here. The meaning of this, like this color combination is that somewhere very much close to around 650 seconds, around 650 milliseconds, at that time this service got initiated and was able to complete the journey. So now to understand that completion of the journey, you can click here. Okay, just a moment. Okay, let me expand it and let me do it this way. So now look, this product stock service almost like initiated at around 842 or 850 ms, and it took 918.398 ms entire journey. So once you click on this, and go to show all annotations, you will understand what I'm trying to highlight. It says that client start relative time around 842 ms, and it was initiated by client. The client name is Take Effects Product Inquiry Service. Okay, then the servicing started somewhere like 1.22 seconds, and at that time a Take Effects Product Stock Service was called, and the response client has received around 1.78 seconds. So it took somewhere, client initiated, the request initiated at 842 ms, and client finished that journey around 1.761 second. So we can say it took around 1 second time. Now coming to product stock service response. So product stock service responded around 1.764 seconds. So this is what is the journey we are talking about. So if you can see, if you see this, that if this is the start point where 0 ms is written, then the whole journey took 1.844 second. So first the entire journey, it took from 0 to 1.844 second, and within this time frame product stock service had responded. So got initiated around somewhere 800 ms here in this point, and around 1.7 second he was able to serve the request back. So this is the tracing you can easily understand, and wherever you find wherever you want to debug your microservices, where in real time scenarios where you got multiple microservices, and there are chain of requests happens. I'm talking about API to API call. So suppose you got 50 or 30-50 microservices, and in normal scenario each microservice communicates to 4 or 5 more endpoints or the API of different microservices. You will be able to trace the entire calling journey, and you will be able to understand where is the bottleneck. So as I've shown you, if you look at the turnaround of product stock service, his turnaround was faster than the turnaround of the product inquiry service. Because look, when inquiry service got initiated, it took almost 700 milliseconds to initiate the product stock service. Right. So this is what actually you can understand through this Zipkin tracing. Now I'll show you another scenario where we had initiated our request from Spring Cloud API Gateway Service. So in that case, go to this. Now you will find 3 entries, right? So it shows that, okay, Spring Cloud API Gateway had initiated the product inquiry, and product inquiry had initiated the request to product stock. So let's go one by one again. So what we are saying, the entire journey took 374.521 milliseconds. It's entire journey. Within this entire journey, if you look at calling as a client, cloud API gateway, as a client initiated the request somewhere around 100 ms time. So 0 to 100 ms, the API gateway was busy, and then API gateway woke up and executed the further as a client, as a request to product inquiry service. Now if you look at the product inquiry service got a call around 200 ms. So look this time lapses. So when we hit through Postman, we hit at, you can say that at 0 ms. API gateway took little time to initiate to wrap the call and to get prepared for the call, and that initiation time was around 100 ms over here, somewhere very much close to 124. So I am assuming it's 100 ms. Then once the client was ready to request, the product inquiry service got a call request around 200 ms, and it took 66 ms to respond back. So product inquiry service took 66 ms. Within that, the inquiry service requested to product stock service at around somewhere 220, and got response from stock service around 11.889 milliseconds. So this is the journey what exactly we are trying to highlight. And if you look at down, you will understand what type of the get or post method was there, and what was the URL, what was the that's endpoint detail, and what all the classes were involved. So that controller class was product inquiry controller, and then the method was get inquiry of product. So this is what Zipkin can help you, and other than that, you can also put the filters, and you can also define the timings, like okay since in production, suppose your entire service is running since last, say, like 1 month, and you would just want to do some debugging for particular time period, so you can define that time period over here by selecting the calendar date and time. Okay, so last 5 minutes, so I am running this. Okay, I think it was more than 5 minutes, so if I take last 15 minutes, and you get all those responses back. One more thing I want to show you, like if you click on the plus button, you can even filter with the service name. So what I am saying, I just want to see the tracing data only for my stock service. So now I selected stock service, and then span name, I can select the method. So this was the method, and now you see when I run this, you will see the data which are from that method. Okay, stock and this, yes, and if you go and say like okay, not this, so add service name, and I'm saying okay, inquiry service, span name is this. So now in this case, if you go and run, you will find one entry within this 15 minutes. So product inquiry service, and this was the inquiry this thing. So this is the data. So this way you can filter out your results. I'm sure this will help you to configure distributed tracing in your microservices architecture for doing any kind of debugging or to understand the entire API to API call journey. That's all for now. Thanks for showing patience to watch the entire session, and I'm sure there will be a good takeaway from this session. We have covered almost all the major components which are used in microservices architecture. However, there are still many components which we would deep dive in our upcoming videos. I have also bundled the entire source code which we have built during this entire session and uploaded to TechEFX GitHub account. The GitHub URL is mentioned on the screen. You can freely download and use it for your practice. Feel free to reach out to me on my email address mentioned on the screen in case you have any queries or you have any kind of suggestions. Last but not least, please like and share my video. And if you have not subscribed my channel yet, requesting you to please subscribe, and this really means a lot to me. Thanks for watching. See you until next time. Bye bye. Hello and welcome to my YouTube channel. I am Amar Kumar. In this tutorial, we are going to learn how to deploy Spring Boot microservices in Docker container. How to orchestrate Docker container using Docker Compose for running multiple microservices under one network, primarily to enable service-to-service communications. I will demonstrate you how to set up microservices monitoring using Prometheus and data visualization using Grafana. We will also learn to configure various metrics supported by Prometheus inside Grafana dashboard. And last but not least, we will also integrate distributed tracing using Zipkin. Entire source codes used in this tutorial are shared on GitHub for your reference. Please check out the link. And one sincere request, if you have not subscribed to my channel yet, I request you to please subscribe to my channel and get latest updates on my videos. Let's get started. This tutorial is all about deploying microservices inside the Docker container. Let's quickly understand how to set up and configure Docker container in your environment. For this tutorial, I am using Docker Desktop in my machine. You can download Docker Desktop from docker.com website. As you can see here, you can click on Get Started, and here Docker Desktop link is here. So as you can see, there are 3 download links for Mac, for Windows and for Linux. So since I am using Mac OS, I have downloaded DMG file and set it up in my machine. Because I already have it in my machine, I'm not going to download again, and I will directly take you to the Docker Desktop configuration page. So this is the first page you will find once you start your Docker Desktop in your local machine. Since there is no container running, so I've not started any container. And second link is the image link. As you can see here, there are a lot of images which I have already built or I have pulled from Docker Hub. You can find OpenZipkin, MySQL, and this is the OpenJDK14. Since I'm using JDK14 inside the Docker, this is what you need to get it. And Grafana, Prometheus, and there are many images are there. So let's not get into that. I'm going to show you how to build a Docker image. So for now, I'm going to setting page. In the setting page, you will find this general resources, Docker, engine, and another link. So in general tab, as you can see, there's a start Docker Desktop when you log in. So once you check this option, whenever you log in your machine or start your machine, Docker Desktop will be started at the time. So I've intentionally not done that. So going to resource, here you can manage your resources. Currently in my machine, by default, since it's a 4-core and 8 GB RAM machine, by default they have taken two CPU, 2 core you can say, and the memory is allocated 2 GB by default. However, you can change this memory allocation as and when you require. At the same time, you can also change the CPU configuration. You can also have a swap configuration and the disk image. As you have seen here, all these images are somewhere occupying your hard disk, right? So for that you can configure. It all depend upon the usage, like how many images you want to build or run or maintain. So as per that you can configure your disk image size in your local machine, and this is what the location of the my disk for that particular image. Let's quickly go to if you are aware, you can also run Kubernetes within that Docker desktop. This is really a good feature. If you are planning to use Kubernetes, definitely you need to increase the resource, because 2 CPU would not be enough to run Docker as well as the Kubernetes engine. So anyway, I am not enabled Kubernetes for now. So this is what you can do in configuration in a nutshell. I'm not going to deep dive in all these features. The whole objective is to showcase you how to build the Docker container and deploy on the machine. So I'm going back. So if you want to run any images, either you can directly click on run, or you can run through the command prompt. So not to worry, I will be demonstrating you how you can build Docker image and can run inside the Docker desktop. For this tutorial, we are going to use primarily 2 microservices. One is inquiry service and another is stock service. Let me quickly brief you about these services. Both these services are built on Spring Boot framework and using Spring Cloud components. Inquiry service requires input parameters which are highlighted in red, like product name, availability and product unit. These are the input parameters required to call a stock service, which we'll see later. As we can see, there are a couple of additional fields highlighted in blue. These are product price, discount offer, which will come from stock service as an output. Total price is calculated based on the product multiplied by number of units. Inquiry service calls stock service through OpenFin client library, which is injected in REST controller endpoint. If you are not familiar with Fin client, not to worry. Let me quickly tell you, you can consider OpenFin as an alternate of REST template. Later, you can download the source code and go through with that. If you have any queries, please let me know. I am running inquiry service on port 8700. Now, let's have a quick look at stock service. Stock service provides the information about product's stock availability. Stock service input parameters are the product name and the product availability field, whether it's available or not, as highlighted in red color. Stock service returns product price and discount offer associated with the product, highlighted in the blue. For demo, I have used H2 database to store entity values and using Spring Boot's JPA repository with H2. Stock service is running on port 8800. For Spring Cloud components, I am using Netflix Eureka naming server for service registry and discovery, and using Spring Cloud API gateway service for routing API request to the destination. Now, let's understand component architecture and integration flow used in this tutorial. As you can see in this diagram, user request for API access will be passed through registry server to fetch the network location of that service. If you are new to service registry, let me quickly explain you why we need service discovery. Generally, in a conventional SOA ecosystem, services network location would hardly change, right? Because they are deployed in local data centers. But in cloud ecosystem, you cannot restrict it by providing hard-coded network address to any service, right? One of the reasons is services instances are dynamically managed and orchestrated by container. That's the reason, as we can see in the second step, the registry server will provide the network address of inquiry service to the user call, which is running on port 8700. And this inquiry service calls stock service as a third step. Inquiry service is calling stock service through Fin client, which is running on port 8800. You know that microservices are independent deployable unit and can be accessed by any service. The same you can see at fourth stage. User can directly access stock service on port 8800. If you look at fifth step, we can access the inquiry service by enabling routing through Spring Cloud API gateway server as well. If you want to learn how to write routing, please check out my video for microservices with Spring Boot and Spring Cloud with example. The same, you can find the link in the suggestion box as well. Now let's come to the monitoring section. Prometheus is an open source system monitoring and alerting toolkit for your microservices health monitoring. It has a set of metrics which can be enabled to find the system's health. In this example, we are going to monitor all these 4 services, which is Eureka Discovery Service, Inquiry Service, Stock Service, and API Gateway Service. Prometheus will collect metrics data from all these services through Spring Cloud Actuator and send it to Grafana for visualization. In this tutorial, we will see how to integrate monitoring on your microservice. For now, let's move to other component, which is Zipkin. We all know that Zipkin is a distributed tracing system that helps gather timely data needed to troubleshoot latency problems in a service architecture. We are going to integrate 3 services primarily, which are Inquiry Service, Stock Service, and API Gateway Service to Zipkin. If you want to know more about Zipkin, you can check out the same video regarding microservices with Spring Boot and Spring Cloud. You can find the link in the suggestion box again. Now we will build the microservices and deploy in Docker container locally. We are going to deploy 4 services, and they are Eureka Registry Service, API Gateway Service, Stock Service, and Inquiry Service as depicted in this diagram. All these services are already uploaded to TechEffects GitHub repository. We simply need to clone these repository in local machine and build. Alright, so for that, let's start the command prompt and create a local folder. So let me create a folder over here. So currently this folder is empty. We will clone all those microservices from GitHub repository to this folder. So as you can see here, this is my GitHub repository where I have list of all the repositories. So we'll start from Eureka naming server. So to clone this Eureka naming server, you can go to code and copy this URL. So I'm just copying this URL, going to command prompt and saying git clone, and you have to copy this. So it is cloned and downloaded. So the download size was around 1.93 MB, right? And showing is 100% completed. So if I will see ls-lt. Now you can see this is a folder. Now let's go inside the folder to take effects. Eureka naming server. Sorry. Oops. So all the source that you can see, there is a pom.xml file, there is a src folder, and there is a Docker file as well. I will explain you this little later. Since this is Spring Boot microservices and I have used Maven as a build tool, you can see here pom.xml file. Now just move out from this location, go to the root location over here, and now we will clone another repository, and this is API Gateway. So here is my TechEffects Spring Cloud API Gateway Service. I'll go inside again and I will go to code and I will copy this link and we'll go to command prompt and we'll again apply the same command git clone, and this time we will change the URL. So this time it is TechEffects Spring Cloud API Gateway Service.get. So this also got downloaded, 1.21 MB it shows. Now we will clone the third repository and this is stock service, right? So for that you can go back, and this is what I have, take effects product stock service. Okay, so I'll go inside take effects product stock service. I'll clone this again. Okay, so git clone URL. So this time I'm putting URL take effects product stock service and say enter. So now we will clone our last service, which is inquiry service. Copy and go to command prompt. Again apply the same command, git clone, put the URL, take effects product inquiry service and enter. So you will find there are 4 services cloned over here. So all these 4 services are now available in my local machine. We need to build these services. We will first build Eureka naming server. You have to go inside effects Eureka naming server. Now I am inside this root folder of this Eureka naming server, and we will execute this pom.xml with the maven command. Before we do, let me quickly give you a walkthrough of this Eureka naming server. So I am opening IntelliJ. So this is the Eureka naming server project, which I have already configured in my IntelliJ. Let's review first pom.xml. As you can see here, this is the Java version 14 I have used, and this is what actually I have put the dependency for this Eureka naming servers. So the first dependency is Spring Cloud Starter Netflix Eureka server itself. Second dependency, what you can see, is the actuator. This I will explain later when we'll talk about the Prometheus monitoring at that time. So this is what actually we have as in pom.xml, all these dependencies. As you can see here, Maven compiler plugin also I have put it here. Okay, before we go into building the service, I'll also quickly give you a heads up about application.yaml file. As you can see, this is that name of the service, take effects Eureka naming service. I have enabled distributed tracing here. It's running on port 8761. So this is the way you enable actuator. If you want to know more about actuator, you can refer my previous video, which is on microservices in Spring Boot with example. Let's go to Docker file. I'll just give you a quick heads up about this Docker file. The very first line, it talks about the JDK reference. As I've shown you in my Docker desktop images, this is what actually I have downloaded. Open JDK 14. This reference I am giving inside Docker file. Second line, we are giving instruction to copy a jar file from the target location, and this is what the jar we are referring to. This we are copying from target to app.jar. And third is Java environment, that OPTS, the heap setting. I am not putting any values here and using default. The fourth line, expose 8761, it talks about the port number on which this service is running. And the last is, we are going to highlight here the java-jar command. This is what we are trying to highlight here. So this Docker will be applying java-jar command with that jar file name. You will need to create Docker file and keep in the root folder of every microservices, and you will have to give reference of this bare minimum these are the settings you need to configure, you need to put in Docker file. Every microservice, I'm going to create file in their root folder. So this is what actually we are referring. This is take effects Eureka naming server, and on this root folder this Docker file is available. So now we can go back to command prompt and we can build this service. So for building a microservice, since we are using Maven, so here is a command mvn clean compile package and enter. It will take a little while. Okay, so build is successful. As you can see here, test run 1 failed 0, error 0, skipped 0, and finally we are getting build success message. The second thing what we have to do is we need to apply the docker build command to build the Docker image and push it to Docker desktop. For that you have to apply the command. I am little lazy typing the whole command, so what I have done, I have copy pasted. This is what the tag we are saying, colon tag. So since I am not using any tag, so latest is the default tag, and then we are saying once this finishes, it will build the Docker image in your Docker desktop. So let's apply this command. And remember, this is the exactly those steps which we have referenced in our Docker file, like the copy the target file and then exposing to 8761, putting the entry points, and yes, successfully built. It can, as you can see here, the successfully built, and this is the Docker image ID. So now go back to Docker image. So here in this image you will find one more Docker image got added, and this is TechEffects Eureka naming server. And as you can see, the tag is latest, image ID is exactly this, 30 some alphabet and then 947. If you go back to command prompt, you will find exactly this link. This is what the build ID. Then you can see the created date and time, like less than a minute ago, and this is the Docker image size 238. Now let's build another image. So go back to command prompt, and this time we'll move out, and this time we'll go to TechEffects Spring Cloud API Gateway Service. We'll go inside, we'll apply the same command. You can ambient clean compile package. Let's wait for this command gets finished. So let's apply the Docker build command. Let's change this name. Let's copy this. So we are applying the docker build full create, and you will be wondering, this docker file, this double quote, the value is should be the exactly same what we have named as a docker file. So if you remember here, this is what the docker file we are referring to. This is the docker file, so that name should be exactly is a capital docker file, and this is what actually I'm putting a reference. So if you are using something different, if you are using something different name, you will have to use that same name over here. Now let's apply this command. You can follow these steps. Go back to Docker desktop, and here you can see now this image is built. So what we are doing, we are building Docker images one by one. So let's first build all these 4 images from the microservices, and then I will show you how we can run using a Docker Compose, or even you can run independently. If you want to run independently, as you know that Docker by default, that because since it's a containerized environment, it doesn't allow you to communicate with each other. One Docker container do not know about other Docker container. If you want, if you have written one service to communicate to other service, you will need Docker Compose. Now let's build our third service, which is stock service. So for that, let's go inside the stock service, apply maven clean, compile and package, and enter. It got built. Now let's apply a Docker image command. Go to Docker, and you can see this product stock service is built now. So now let's build our fourth service, which is inquiry service. Okay, oops. I had a spelling mistake in package, so that I rectified. So inquiry service is also built successfully locally. So now let's apply the command for Docker build. Let's change this. Inquiry service. Okay, this one is spelling mistake. Yes. Go back to Docker desktop, and we have our all 4 microservices images available in our local repository. By the way, I just forgot to mention you about the remote repository. This remote repository is the Docker Hub repository. For that you will have to log into Docker Hub through Docker Desktop. So as you can see here, this is my personal Docker Hub ID, and this is what it shows here. So I'm already logged into Docker Hub, and these are the 2 repositories I have pushed on Docker Hub. When we say Docker Hub, it's a Docker Cloud, right? So this is all our images I have not yet pushed to Docker Hub. It's all available inside Docker Desktop, which is running in my local machine. So next step is, let's create a Docker Compose YAML file. I have already uploaded a YAML file to TechEffects repository, and this is what that repository name is. So let's clone this repository now in our local machine. Go to command, that's it. So as you can see here, TechEffects Docker Compose workspace is created. Let's get inside the workspace and see what is there inside. So you will find there's a Docker Compose YAML file, and there is one folder called config. Let's examine this YAML file and what is there inside the config file. So I'm going to IntelliJ. I've opened this project inside the IntelliJ. So as you can see here, this contains a Docker Compose.yaml file, and inside the config there is a Prometheus.yaml file. This I will talk about later. Now let's examine what is there in Docker Compose.yaml file. So as you can see here, this Docker Compose YAML file starts with a version ID. This is mandatory, compulsory. You will have to put any version number, and then there is one command called volumes. This we require for Prometheus data. Now let's understand this service tag. Within the service tag, we can see there is a couple of microservices injected, and this is exactly the TechEffects Eureka naming server is the name you can provide. You can provide any name, and this is the image reference. This image reference is nothing but your Docker image reference. So inside the Docker Compose, exactly the same name is available. This is what actually it's referring to. Next line is port number. If you remember, we have run Eureka naming server on port 8761 to expose to 87614. This is what the Eureka naming server Docker file. So this is exactly the port number which we are referring to. And then there is one tag called networks. As I had mentioned you earlier, through Docker Compose, you can create a virtual network. Through that network, your multiple microservices can communicate with each other. So this is what the virtual network we have created here. The network name is test network. This actually, if you look at the bottom, this is what the tag we are referring to. This is networks tag, and the name is test network. So created network here in the name of test network, and this we are referring in each and every microservices. Then we are talking about the second microservices, and this is TechEffects product stock service. Again, the image reference is taken from the Docker desktop image reference, and since this requires couple of environment variable setting, so that is the reason through this environment tag you can set up the environment variable. If you want to understand what these variables are, I'll quickly update you. This is a Java OPTS inside the Docker. So where we are saying my variable name called Eureka server, this is the environment variable and this is the value. Likewise, if there are any environment variable referenced called Zipkin server, then the address will be like this. This is how Docker understand the URL. If we put localhost :8761, Docker will not be able to identify or access localhost from Docker container. We are using these names here. So this TakeEffects Eureka name server is nothing but is this TakeEffects Eureka naming server. So whatever service name you are going to put there for each microservices, the same will be referenced for that particular microservice if you want to access. Likewise, as you can see, Zipkin server, the value is http :zipkin :9411. So if you go down, you will find there is a Zipkin service we have created, and the name is Zipkin. So this we are referring, and if you look at the port 9411, this is the port exactly we are referring here. Now let's come to next tag, and this is depends on tag. So basically depends on tag allows you to put dependency. So like you want to run this TakeEffects product inquiry service with some predecessor. So this TakeEffects product stock service is the predecessor for inquiry service. This is what we are talking about. What we are saying that before you run TakeEffects product inquiry service, make sure that TakeEffects product stock service runs. So far we talked about Eureka naming service, stock service and inquiry service. Now let's talk about our fourth microservice, which is TakeEffects Spring Cloud API Gateway service. So again, all the tags will be the same, only image reference will be changed since it also has the environment variable dependency of Eureka server and Zipkin. So this is what actually we put. So here for Cloud API Gateway service, we are saying the it will run on port 8900 and expose to 8900, the same. And you can see here depends upon. So this API Gateway server has got 3 services dependency. So it says like dependency on Eureka naming service, inquiry service and stock service. Now let me quickly explain you, like we are also running Prometheus and Grafana as a monitoring solution, and we are running as a Docker image only. That is the reason we have put here Prometheus and Grafana's reference. I'll explain you when we'll talk about monitoring solution. So this is what our docker compose.yaml file. Okay, you can keep this docker compose.yaml file anywhere. Currently I have kept docker compose YAML file in this location, TakeEffects services and docker compose location. If you want to run this docker compose, you simply need to put docker compose up. Once you enter this command, it will run all our services, whatever we have referenced inside docker compose. So far we have learned how to configure multiple microservices inside docker compose, right? And we have configured our 4 microservices: Eureka naming service, stock service, inquiry service and API gateway service. Now let's understand how we can configure monitoring with microservices using Prometheus and Grafana. Before we come to this services detail, let me just give you a brief about how we can download the images of Prometheus and Grafana, and one more component called distributed tracing with Zipkin, right? So let's visit to hub.docker.com. So if you open the link of hub.docker.com and search for Prometheus, you will be getting multiple list of different sources of Prometheus. I would recommend you to please search for prom/Prometheus. This is what actually I'm using in my machine also, and this looks like this is an official image. Once you search for prom/Prometheus, you will find a docker pull command. Alright, So you can copy this docker pull command and run on your local machine command prompt. All right. So once you do that, it will pull the image of Prometheus from Docker Hub to your Docker desktop, and it will be listed out here like this. Similarly, you can also search for Grafana /Grafana inside your hub.docker.com, and you will be ending up with this page, and there you can copy the link of Docker pull and apply this command on your local machine, and the image will be copied from hub to your Docker desktop, and same applies for Zipkin. So this is the OpenZipkin /Zipkin what actually I am using. However, you can use any version or any sources of these components. It will be like a more or less it will be similar, but since I have not used other version, I would recommend to try this. Now we have all our microservices image built. These are the 4 microservices. Then we have Zipkin, then we have Grafana and Prometheus. Now let's understand how we can integrate these 3 components inside Docker Compose. For that, let's open Docker Compose. So as you can see here, this is how you can inject a service of Prometheus. So you can give any name. So here I am giving the name of Prometheus as a Prometheus only. Then the image reference, this will be by default taken that from the Docker desktop. One more thing, it requires an additional tag called volumes. The reason is you will have to give reference of your config file, where this config file is located. When we use volumes tag, we provide the reference of your config file. There are, however, a couple of additional references as well, but those are not that mandatory. But giving a config file is a mandatory. I mean, you will have to put this. Similar to that, you will also need to have a command reference, and inside the command, as you can see, there are multiple key values. You have to provide at least config.file keys and value reference inside the command. Others are, even if you can comment out, there won't be any kind of issues, but you will have to provide a config file. If you don't provide config file reference, by default this is the value it will be taken. Anyway, I have not made any changes, so even if I comment out this, it will work because it's a default value. Alright, so now let's come to next tag. This is a port. As you guys are aware that by default Prometheus port is 9090, and here we are seeing also expose it, the same port exposed to Docker container as well. Again, the depends on is not compulsory. Here just like I have put as a reference purpose, you can even remove that. One very important thing is network, right? Coming to next component, which is Grafana. Compared to Prometheus, Grafana is very much straightforward. You just need to put image reference and the port number, and again the dependency. Here I have intentionally put the dependency of Prometheus because I want this Grafana to be loaded after Prometheus gets loaded, right? And the network again, the setup, and last but not least, this is the Zipkin, right? And this was the reference we are providing. Zipkin requires an additional environment variable reference. As you can see here, that environment variable name is storage type and value is MEM. MEM refers to in memory. There are multiple data types available in Zipkin. Elastic could be one of the data types. Then even database like a MySQL or Postgre or any other database can be one of the storage type. And even you can use queuing service as a storage type, so like RabbitMQ or something like that. Okay, so these are the various storage type you will have to put, and rest of the tags are almost very common tags like a ports. As you know that Zipkin runs on, by default it runs on 9411, and this is what the dependency, and network again. This network, test network, refers to finally the master tag called networks. So this values and these values should match. So this is what is all about Docker Compose. And one more YAML file, let me explain you. I just missed that. Whenever we are configuring Prometheus, remember, like we were talking about the config file. So config file is a must, a reference of config file. So where this config file resides? In my machine, this config file, so this volume is basically a logical volume where we are saying .config and the volume detail is etc Prometheus. So what it will do, when you execute this Docker Compose, it will create a logical volume in your machine where this YAML file is kept. So in this case, this YAML file is at the location of, if you go to the command prompt, so in this location it is there. So takefx services / takefx Docker Compose workspace. So wherever this YAML file is there, so Docker Compose YAML file will be there, it will create a config volume. So this config volume will contain Prometheus.yaml file. This is what that is mandatory. So so when we are putting the volume of config and this file reference, it will pick the Prometheus.yaml file from that location. So let's quickly understand what all the different configuration we require to do in terms of Prometheus monitoring. So very first thing is a global setting parameter. This global setting parameter says it has two variables called scrap interval and called evaluation interval. The meaning of this is every 5 seconds the result should be populated in terms of performance matrix. Every 5 seconds, right? So now coming to the next config element. This config element has got a job element, if you can see. So suppose if you want to monitor any services, you will have to create a job for that service. This job name is nothing but a unique identity of, basically a unique name, because I am going to monitor stock service, so I am giving the job name as a stock service, and this scrap interval 5 seconds. So this, if you are reapplying over here, if you are reusing this inside this job name, it will overwrite the default, the global setting of that is scrap interval. So if you are putting a scrap interval 15 seconds and here 5 seconds, this 5 second will be overwritten by 15 seconds. Okay, so this will be applicable. Now the matrix path actuator Prometheus, this is required. So as I had mentioned, Prometheus gets the health data from Spring Boot actuator. How that I had shown you. Let me revisit to that page. So as I had shown you earlier, you will have to enable actuator inside your POM as a dependency. So this is how we have done. So here we have provided the dependency of actuator, and then inside the application.yaml file, this is how we are injecting. We are saying, okay, enable the health monitoring, actuator health monitoring through this setting. So we are saying management.endpoints.wave.exposure.include equal to star, and we are saying health show detail enable always. So we will have to put this inside your YAML file. So this is how you are enabling actuator. Let's go back to our Docker Compose workspace. So this is exactly the URL. This is default, by default endpoint. So I'll show you this later by executing this, because that we have not yet started running the service. This will not appear, right? So once we start the service, I will show you how this endpoint look like. Okay. The second configuration element is a target element. This is how, like what we are saying, that because we want to monitor stock service for Docker, this is the address. If you will use localhost, Docker will not be able to access localhost. However, you can, through your browser, you will be able to access localhost. But Docker, when we run any Docker image inside the container, it will not be able to communicate with your local machine. Basically, when you run any service inside the Docker container, you will have to give the URL with the name of that service. So this is the service what we have configured inside the Docker Compose, right? So if you go to stock service name, so this exactly you need to copy this and put inside this prometheus.yaml file, and you have to give the port number on which you are running particularly that service. So whatever service you want to monitor, you will have to put as a job inside the prometheus.yaml file. So here, for example, we are going to monitor stock service, next is inquiry service, naming service, and even API gateway service. So we are going to monitor all these 4 services, and the target will be defined with the service name and the port which we have exposed to. Okay, so this is how we can configure Prometheus. And now let's go back to Docker Compose, and just from top to bottom, let's understand like whatever we have configured. So we are saying we have configured services element. Inside the services we have naming service, we have product stock service, we have inquiry service, API gateway, Prometheus we have configured, Grafana we have configured, and Zipkin. Now if we run this Docker Compose, what will do? It will execute all these Docker images as per what we have defined in this Docker Compose config file. Alright? Okay. Now let's execute this Docker Compose file. So now we are on command prompt, and now let's execute Docker Compose. So this is the place. So let's come out from that config. Let's go to directory where Docker Compose.yaml file is there. So to run Docker Compose, you have to apply the command docker compose and simply up. Let's apply this command. So as you can see, whatever images as a service we had listed, it's now executing 101. It will definitely take little time because we are almost running 7 services. I mean 4 microservices and 3 components. So it will take little time. Services are getting loaded here. Alright, so if you click on any service, you will exactly be able to see the log and see like the status. So I'm inside the Eureka service and see service started Eureka service. I'm going back and checking this. Zipkin is also showing the Zipkin is up. Okay, I hope all the services are up and running. Cool. So let's go to command prompt and see. I think yes, all services are running. Finally, Eureka naming service is running. So now let's go to browser and check a couple of things. So as I told you, the Prometheus by default runs on 9090. Alright, so going inside the status configuration, you will find this is exactly the same configuration what we had shown you in IntelliJ. Alright, so this is what exactly so it's referring to. So we have kept this prometheus.yaml file here and kept in config, and it is referring exactly the same config file. So as you can see, job name, stock service, inquiry service, naming service, and the finally API gateway service and their addresses with the port details. Now you can Prometheus comes with presets of performance metrics. There are many presets. Like if you can just press space bar, you can find there are so many performance metrics presets are available. Select system CPU usage. I'm just trying to select one, and I'm saying execute. So now you can see the values, right? It shows 4 lines. The meaning of this 4 line is each line for each services which we have enabled inside the Prometheus, right? So here is for naming service is saying, so system is up by 0.08 seconds, and inquiry service again same, and all this data. If you can go and again press this thing and say like, okay, I want to see system CPU count, or say like I want to see process CPU usage. So this is what the data is. Now we will render the same data in Grafana, because as you can see here, these data are so much very much vanilla kind of. However, it provides a graph. So if you click on this graph, you will be able to get the graph, but still like these graphs are very much kind of very vanilla kind of. So if you integrate your Grafana with Prometheus, you will be able to get a better visualization. How? I'll show you right away. So if you remember, we have configured Prometheus on localhost 3000. So this both Prometheus and Grafana both are running as a container service. Okay, it's not really running in your machine. It runs on the container configured on your machine, right? But still I am able to access this as a local host. See, you can access container URL through localhost, but container will not be able to access your system, right? This is what actually I am trying to highlight here. Unless you configure that as a volume or as an environment variable. So the default login is admin for Grafana. So I'm logging here. I'm just skipping. I'm not resetting the password now. I'm just skipping this. Now very first thing what you have to do is you have to go to setting. You have to add the data source. So clicking on the data source, there are various data sources are available, right? There are many data sources that Grafana supports. So since we want to add Prometheus as a data source, so this is how we will say select. As you can see here, if you are going to put localhost HTTP, I'll just try to show you, localhost colon 9090 and say save and test, it will fail. It will say the data source added, but then it's not able to ping to that data source. It's saying HTTP error bad gateway. So this is what actually I want to highlight you. To access Prometheus actual data source, which is running as another container similar to Grafana, you will have to give the name of that service. So inside the Docker Compose, we had given Prometheus name as a Prometheus. And then if you go and say save and test, it's working now, right? So going back, so we have configured Prometheus as your data source. Second thing what you have to do is you have to go to either create the dashboard or import the dashboard or provide any reference of the existing dashboard, right? So I'll just show you a couple of these things so you will understand how to create a dashboard. So I'm just clicking on plus, and here when you go to create dashboard, you will have to add panels. So panel means the matrix, basically what you have to define. So you have to go to here, this place, here you need to select Prometheus, and then you have to select matrix. As if you can see my mouse movement, so these are the different matrix category. These metrics were also visible inside the Prometheus, right? If you remember, so when we were doing like this, so all these metrics list, the same is appearing over here also. So I'm just to show you as a demo, or I'm just selecting this up value. So the time I selected up, and I'm saying okay, system up metrics, okay, and you have to apply save. Now here by default is a 6 hours, right? If you select 5 minutes, so you will get the system up detail. Alright, you can also configure some different metrics. Say like, okay, this time, okay, I'm taking process system CPU usage, right? The time you are taking system CPU usage, you can say like CPU usage and apply. So last 5 minutes system usage are there. So you can click and get each service's health status of usage, that CPU usage. Alright, so now I'll see, I'm not going to cover everything. My intention was to just show you like how you can configure Grafana with different Prometheus metrics, and you can try one-on-one all these metrics, and I will also tell you how you can even design your dashboard. So everything is like movable, so you can design this way. You can even resize the panels. Even you can resize this panel, right? And you can keep on adding as per your requirement. So this is the way you can create a dashboard. Okay, right. So I will show you. I have created one sample dashboard. So what I will do now, I will show you how you can import existing dashboard, right? So say like, okay, I'm going to dashboard. I'm saving this dashboard. Like my sample one. I'm saving, right? I'm going to dashboard. This, whatever the value is you're saving, this dashboard appears in your dashboard section. You can have multiple dashboards, alright? So I just wanted to show you how you can import a dashboard. So just go to plus sign and check this import. You will be coming to this page where you have two options. Either copy paste your JSON directly over here, or you select a JSON file to get uploaded. So I'm just trying to show you like, okay, I'm going with upload feature. So actually I have copied this sample dashboard here, my custom dashboard Grafana, 3x3, something like. So once I import it and I say okay, import, this is what the sample dashboard I had created once just for demo purpose, right? So there I have created a various different metrics. One is a system up metrics, and the system load average, CPU usage, one is the system CPU usage, other is the process CPU usage, process uptime, process start time per second, JVM, even JVM like a performance you can monitor, even that HTTP service request and response you can count and monitor. So I would request you to go and explore all these metrics what is provided by Prometheus. So this is what all about monitoring with Prometheus and Grafana. Now let me quickly show you how you can integrate Zipkin with your microservices for distributed tracing. So as remember, we had made Zipkin running on port 9411. Alright, so now let me go back to Postman and let's run a service called stock service directly. So here I am trying to access the stock service which is running on port 8800 directly. So I'm just clicking on this. Here you go, right? So you are able to fetch the data. This data is coming from where? It's coming from the Dockerized container which is running inside your Docker desktop. This time I will try to access stock service through inquiry service. My inquiry service runs on port 8700, right? So if I hit this link, what it will do? It will first go to inquiry service, and inquiry service internally calls stock service. Okay. The third way of doing, if you remember the integration flow, the third approach was like even you can access inquiry service through your API gateway. So your API gateway is running on 8900, and this is the URL, this is the endpoint which we have mapped inside API gateway as a route, right? And now trying to access this. Okay, so we have hit 3 times the URL. One was directly through 8800, second was through inquiry service, and third we are hitting the inquiry service through your API gateway configuration, right? So now let's go to browser and see how Zipkin can help you to give you the trace of each service calls. So remember, these are the 3 traces, right? Each traces has its own span inside. Okay, each trace has its own span defined. So each trace has the default trace ID. So as we had hit first stock service directly, so this is the first one call it shows. In this case, we have hit through inquiry service, so the trace starts from inquiry service and then goes to stock service. Likewise, in this third call where we had hit stock service through API gateway, so API gateway was calling inquiry service was calling stock service. Alright, so if you go and just check this detail, so just click on the show button and it will be able to give you the complete trace and span detail. If you want to learn more about Zipkin, I have already created a detailed video how to integrate Zipkin and how Zipkin can help you to debug the microservices issues. So please check out my that other video. I will post the link in the description box, and the same you can also get it through the suggestion box. So let me summarize. We had defined 2 services, Both were registered with Eureka naming service. We had deployed all those 4 microservices inside the Docker container, and we also executed 3 components, that Zipkin, Grafana and Prometheus as a Docker container, and we are able to get end-to-end service monitoring. That's all from this tutorial. Hope you guys find this tutorial informative and useful. Please let me know in comment box if you guys have any suggestions or need to get any clarifications. A quick update about my upcoming videos. Very soon I am going to upload a tutorial on how we can deploy Spring Boot microservices on Kubernetes platform and how Kubernetes orchestrates microservices. In my another video, I am going to demonstrate you how you can integrate ELK stack with microservices for log management. Last but not least, I sincerely request to you all, if you guys have not subscribed to my channel yet, please subscribe to my channel and get latest video updates. Thanks for watching. See you until next time. Microservice architecture has transformed the development landscape for both web and mobile applications, offering a paradigm shift in its stateless nature and loose coupling. This innovative design allows for creation of native mobile applications that leverage the same backend services during web application frontends. The concept of building once and utilizing multiple use cases has become a prevailing norm in enterprise design patterns. To address the scalability demands of numerous calling clients, notable strides have been taken in containerization and orchestration strategies, particularly on public cloud platform. However, these scalable design techniques have inadvertently increased the exposure of backend services to potential security threats, expanding the attack surface and associated risks. On top of it, the mix of heterogeneous technologies in microservices architecture, their distinct logging strategies makes the central logging difficult, which in turn loosens the security. Additionally, the complexity around building the resilience for fault tolerance across the decentralized networks adds to the security loopholes. The simple security designs which were once used with traditional web applications cannot be used for microservice-based applications. Unlike traditional web applications, simple security designs are insufficient for microservice-based applications. This need. Fourth is encryption everywhere. Services can be decomposed efficiently using various